Welcome back. So in this video, this is going to be solving linear equations part 1. Because the first time I did this video, it was about an hour long, and when I went to edit it, it had no audio. So I was going to chop the video in half, but since it didn't have any sound, here I am recording it again. So hopefully this one will work. So don't worry too much about the word linear. We'll get to that later in the unit. So just think of it as solving equations for now. So I've drawn a little picture of like a old-fashioned balance scale. And solving equations essentially, I suppose the way to think about it is an equation is like a mathematical expression that has an equals in it, and the equals kind of means that what's on both sides of that equals is the same. It's equal to each other. And the idea with solving equations is we can manipulate or rearrange those equations, and as long as we do the same thing on both sides of the equals, then the equals will always be true. That's kind of what we're aiming for, to make sure that whatever we do, we're not changing the fact that that equals in the middle of the two sides of the equation, keeps things balanced. So the idea with the balance scales is if they are already in balance, we could add something to one side, and as long as we add the same thing to the other side, it'll stay balanced. So we could add 2 here, as long as we add 2 there, and it will still be balanced. We could double the size of what's on both sides, so we could multiply by 2, multiply by 2. We could take things off. We could take away 7, as long as we take away 7 things from there. And it doesn't really matter what you do, as long as you do the same thing on both sides, then the equation is always going to be balanced. So in saying it doesn't matter what you do, when we're trying to solve equations, we are essentially going to be picking the right thing to do on one side so that we rearrange our equation to reveal the unknown thing, so to speak. So as far as normal mathematical problems, for most of your mathematical learning, you would have seen things like, let's just do a simple example, 2 plus 3 equals, and then a big empty space where the answer goes. So essentially, let's just put a box around it. This is the thing we don't know. And the only thing that is sort of new in this, dare I say the word, algebra side of things, is the thing we don't know isn't necessarily on one side of the equals. So we know this equals 5, so we could write 2 plus empty box equals 5. And so the thing we don't know has something happening to it mathematically, but we know what it equals. So some unknown thing, we know it's that. But after you add 2 plus this unknown thing equals 5. So the idea is we need to get the unknown thing on one side of the equals and all the numbers on the other. And we sort of go through this balancing process of choosing the thing that we need to do to try and get the unknown thing on its own. That's essentially the gist of the process. So what I've written here on the side is kind of a bit of guidelines towards how we decide what to do. So with addition and subtraction, they are essentially, they are operations that addition is the opposite operation to subtraction, and subtraction is the opposite to addition, and they essentially undo each other. But the thing with and the same sort of goes for multiplication and division. They undo each other too. But the thing to be aware of is when we're adding or subtracting, the idea is we need to make, for example, in this situation, to make this 2 disappear and end up on this side of the equals, we need to work out what we need to do to this whole side to make the 2 go away. So really, with addition and subtraction, we're looking for the thing that we do. What can we do to the 2 to make it into 0? Because the special thing with addition and subtraction is, so, well, let's say 7, when we add 0, it equals the same thing. There's nothing special about that. Or 7 subtract 0, it equals the same thing. And that's sort of what we're aiming to do with this. So really think about when we're undoing something, we're trying to turn the number that's being added or subtracted into 0 on one side of the equals. With multiplication and division, the thing that in the way that addition and subtraction, we're looking for to make something disappear. With multiplication and division, the thing to look out for is we're trying to turn the thing that we want to move into 1, because when we multiply something by 1, it doesn't change. So 7 multiplied by 1 equals the same thing, and the same 7 divided by 1 doesn't change it. So addition and subtraction, try and think of how do we turn something into 0, and multiplication and division, how do we turn it into 1. Right, in saying that, I think we should maybe just jump into some examples. So we'll start off with some that aren't too difficult, and only one thing is happening to the unknown in this first lot of examples. So it's sort of the first we'll do some of these, then we'll do some of these, and I reckon that will probably take us to the end of this part 1. In part 2, we'll look at some slightly more complicated examples where more than one thing is happening. Okay, so I'll just write out the first few of these. So this is the 1.6. So let's just write these out. So I'll do the top row. X plus 3 equals 8. X plus 2 equals 7. And x take away 6 equals 5. Okay, so let's just separate these. Okay, so this is the first few examples. We've got quite a few of these. So really, this x is the thing we don't know, and when we have this unknown thing and we add 3 to it, the answer is 8. So really we want to solve it so that this unknown thing is all by itself on one side of the equals, and all the numbers are on the other. Probably worth mentioning that when we have an unknown thing and we call it a letter to represent the thing we don't know, there's no number in front of it, that just means we've got one of them. If there's a number in front, then it's being multiplied, but we'll get to that. Okay, so because we know that this number, the 8, is 3 bigger than this, because after we've added 3, we get to 8. So we want to make this 3 disappear. We essentially want the 3 to end up as 0, and in order to keep the equals the same, or to keep both sides of the equation the same, we've got to do the same thing on both sides. So if we're starting off with our unknown, if we add 3 to it, then the idea is we're going to undo this adding 3 by subtracting 3. So if we add 3 to something and then take 3 away, it's like we're not doing anything. We're sort of adding 0. But if we're going to subtract 3 from this side, we also need to subtract 3 from this side. So really, when we add 3 and then take 3 away, that cancels out. So that's effectively our 0. And we end up with, let's do this in black, we end up with just x on the left hand side, and then 8 take away 3 is 5. That is our solution to this equation. And we can take our answer, or what we think the unknown is, and plug it back into our original equation. So this is sort of substituting, which we will get to in the next video. But essentially, if we put 5 in here, 5 plus 3 is indeed 8. So that's sort of a way to check if we've done the right thing. Okay, the next example. Same sort of thing. We've got an unknown. Now, these examples do use x in all the examples. Something to be aware of is in each separate sum or problem that we solve, it's okay to use x, but if we have another unknown, we can't just keep calling it x. It always has to be called something different within one equation. So here, we start off with a thing we don't know, and when we add 2, we get to 7. So, in order to undo this 2, adding 2 to something, we're going to, like we did here, take away 2, subtract 2. So I'm writing it underneath, just so it's sort of lined up in that. Take away 2 from this side as well, so that the equals is still true. So here we add 2, we take 2 away, it's like adding nothing. So we end up on this side, that cancels with that, and we end up with x equals 7 take away 2, it's 5 again. Same solution as the first example. And again, we can go, if we imagine that that's a 5, and then we add 2, we do indeed reach 7. Okay, so here we've got, again, an unknown number. After we take away 6, the answer is 5. So we need to get rid of this take away 6 from this side. We need to undo it and try and move that to this side of the equation so that we have x on its own. So if we're taking away 6, just the way to undo that is to add 6. And we've got to do that to both sides, so we're going to add 6 over here. And so if doesn't matter what we start with, if we take away 6 and then add 6, it's like adding nothing. So this cancels out and becomes like it's not even there. So we end up with just x on the left hand side, and then we have 5 plus 6 is 11. And if we were to substitute 11 in here, 11 take away 6 is 5. So that's a way to be able to check that you're on the right track. Okay, I'm going to rub these out. We're going to do the next lot. So I think we've got quite a few more. So I'll write these ones out as well. Let's take 8 equals -2. So we're starting to get into negative land. The next one, 4x equals 16. -3x equals -12. Right, so just so we don't get confused between these. Okay, so this first one, similar to the examples we've just done. We're starting with some number that we don't know, and when we take 8 away, we end up at -2. So the idea is we want this take away 8 to disappear, so we're going to undo it, and we want to essentially make that take away 8 turn into a 0. So we're going to, on this side, we're going to add 8, and we have to do the same on this side. We add 8. So over here, something we don't know, we took away 8 and then we added 8 back on, so really it's like nothing happened. So we get a cancellation over here. And then if we're starting at -2 and we're adding 8, we end up at 6. So that's a +6. So if we plug that in here, +6, take away 8, does indeed take us to -2. So that's the idea with addition and subtraction. To make things disappear on one side, we have to undo them by working out how do we turn what's happening into 0. And then we have to do that same thing on the other side of the equals. Okay, so these next few examples involve multiplication and division. So here we have 4x. So there's no add or subtract in there. So this is essentially x plus x plus x plus x. So we've got 4 lots of x. In the same way that if we had 3 plus 3 plus 3 plus 3, we'd have 4 lots of 3. So this is sort of the way that we write when we have an unknown. A number in front means that these two things are actually multiplied, because we've got 4 lots of x. So if this is 4 multiplied by x, then the way to undo this multiplying by 4 is to divide by 4. So the way I'm going to write this is as a fraction. So I'm going to divide by 4 like that, divide by 4 like that on both sides. So essentially 4, how many 4s? Well, 1. So we've turned this 4 at the front, by dividing by 4, we've turned it into 1 lot of x. So on this side, those cancel in the same way that a normal fraction would cancel if we had the same thing on the top and the bottom. And over here, we've got 16 divided by 4. So if we just write the next line, we've got x on its own now, 1 lot of x. 16 divided by 4 is 4, because 4 times 4 is 16. So if we plugged in this 4 into here, 4 lots of thing we don't know, 4 times 4 is 16. So that confirms that we've got that one right. Okay, same thing here. Except we've got a negative number. So here we've got -3 multiplied by x, and this equals -12. So what I'm going to do, we need to move this -3 to the other side of the equals. So we're going to divide by -3. And because really we don't want negative x, we want just positive x on its own. I've got to divide this side by -3. So over here, -3, how many -3s? Well, there's only one, so that this cancels, and the negative cancels as well. So we end up with x on this side. Then over here we've got -12 divided by -3. So a negative divided by a negative means we're going to get a positive answer. And 12 divided by how many 3s? 4. So if we were to plug x equals 4 into our original equation, -3 multiplied by 4, positive 4, is going to give us -12. Okay, we've got 3 more examples like this. So I'll get rid of these. And let's write these out. So -x equals 10 divided by 4 equals 10. And x divided by 5 equals -4. Okay, again, so I'll separate these with a line just so we don't get confused between equations. So like I said before, when we're not interested in -x, because really this is the same as -1, brackets around that, times x equals 10. So in order to get rid of this negative, we need to divide both sides by -1. It's sort of the same as multiplying or dividing by 1, but what it does do is it flips the positives to negatives and negatives to positives. So on this side, -1 divided by -1, they cancel out. And it's like it turns into a positive 1. And on this side, it's a positive 10 divided by -1. So it's still 10, but the answer becomes negative. So let's write it over here. We end up with x equals -10. I hope that makes sense. So if we plugged -10 into here, in just for x, forget that there's a negative in front of it, because when we plug that in, we'd end up with -10, which would give us the +10. Okay, this next example, we've got something we don't know. When we divide by 4, we end up at 10. So because we're dividing by something, in order to get rid of this 4, we need to then multiply by 4. So we're essentially undoing what's going on over here. So what I'm going to do is just write out x divided by 4. I'm going to write this out again, except what we're going to do is multiply by 4 on both sides. So multiply by 4. So notice I've got a straight line cross for times. We're keeping the x curly so that we don't get confused between our unknown numbers and our operations. Multiply by 4 over there. So here we've got our unknown thing multiplied by 4, divided by 4, so they undo each other. So we end up, that cancels with that, and we end up with x equals 10 times 4 is 40. So if we, just to check again, if we were to plug 40 in the top of our fraction here, 40 divided by 4 does in fact equal 10. And same thing with this last one. The only difference is we've got a negative number here, so we've got to be careful with the sign of our answer. So again, in the same way, I'm just going to write out what we've already got, leave a bit of space, equals -4. So the thing I'm changing is I'm going to multiply both sides by this 5. So over here on the left we get cancellations, and on this side, don't forget that's a positive. So we've got 4 times 5 is 20, and a negative times a positive is going to give us -20. So our final answer, -20. So just check, if we were to plug in -20 in our original equation, -20 divided by +5 is going to give us -4. I hope that makes sense. Okay, so I'm going to end this video here. It's already getting a bit lengthy. And in part 2, we will look at some solving equations that have more than one thing happening to the x. So we need to think about what order we do the undoing to try and get the x or the unknown term on its own. Right, so I'll see you in the next video.